Okay, so for today for notes, we're going to start applying the solving of linear equations that we've been working on. And so it's going to add kind of a little bit of a level of difficulty because now we need to know how to solve, which hopefully we've gotten pretty close to mastering the skill of solving a linear equation. And so now we're adding a layer of being able to translate words from an application problem into an equation, and then from there we just need to be able to use our skills of solving to solve. So before we look at our word problems, there's a few kind of tips that I want to give you in terms of how we piece these things together to create an equation. So first, starting with our variable. So in our word problem, a variable is usually indicated by the words a number, or a value, something like that. So anytime we see like 3 times a number or a number plus 4, that is going to be represented with a variable. Our equal sign, sometimes it's just going to say is equal to, and sometimes it just says is. Okay, like twice a number is 4. Okay, so looking for these kind of key words to be able to place our variable in our equation and to be able to place our equal sign. And then we're going to have our various operations. So addition sometimes says more than. For example, 5 more than a number. It could be the sum, okay, of a number. So the sum of 2 numbers. Could be plus or added to. Those are kind of more obvious things. So if we have, for example, so we're going to have sets of examples down here, a number, I don't want that as our example. Let's take that out of there. Let's say 7 more than a number. Okay, if I have 7 more than a number is 10. Find the number. Okay, so there's an example of an application problem. So 7 more than a number is 10. Find the number. To translate that to an equation, we would have 7 more than a number. So you kind of write it in backwards. So I have 7 more than a number. That a number is the variable piece, is 10. Find the number, and so then we'd be able to subtract 7 from both sides and we'd have x equals 3. Okay, so just an example of addition in these word problems. For subtraction, it might say the difference. Okay, so just like sum is our fancy word for addition, the difference of would be our fancy word for subtraction. Could say less than, minus, or of course subtracted from. And so this one's, we want to be really careful with subtraction. So if I had something like 5 less than double a number is 11. Okay, so to set up this example, 5 less than double a number. Order matters here. So I have 5 less than double a number means I have 2x. Okay, that a number, that's our variable. Double a number would mean I have 2 of that number. And 5 less than that equals 11. So whereas on my addition, it wouldn't really matter if I wrote it 7 plus x or x plus 7. It would still be fine either way with that addition piece. But with subtraction, it would be very different and I would get a different answer if instead I wrote 5 subtract 2x. So we have to really be careful when we're reading that sentence how it translates. So 5 less than double a number. So the subtraction piece comes second. Multiplication, so we saw in an example here, double a number. So sometimes we see like double or triple. That's indicating that we're multiplying that number by 2 or 3. Our special number for our special word for multiplication is a product. Okay, so the product of two numbers is multiplication. Sometimes we see like times, which is kind of slang for multiplication, or multiplied by. So the product of a number and 5 is 20. So the product, so this piece is indicating multiplication, a number, so multiplication between a number and 5, so 5 times x, is, there's my equal sign, 20. Okay, that's how that would translate. Division, again, sometimes like double and triple, so sometimes it's going to say like half of a number or a third of a number. That would mean we're dividing. Or our special word for division is the quotient, or divided by, and so on. So I think I'm going to skip our example here and move to the examples down below. So first, take a moment and read through our first example. We have the sum of twice a number and 11 is 21. So as I'm reading through this, first of all, I notice right here, here's where my variable is. Okay, that's my variable piece. Here's my equal sign. Okay, and it says the sum. Sum means that there is addition happening between the two numbers that we're talking about. So the sum of twice a number and 11. Twice a number means we're going to have 2 times x and 11 here. Okay, and the sum means that twice a number and 11 are being added together. Okay, so putting that all together, twice a number and 11, so the sum of twice a number and 11 is, there's our equal sign, 21. Okay, so we've now translated the verbal phrase and now we're going to solve. So subtracting 11 is going to give me 10, and then dividing by 2 gives me 5. I'm going to do the last one and then I'll let you try the next two on your own. So last one has a lot of pieces here. So the sum, again, so we're talking about addition, of 6 and 10 times a number. So 10 times a number, meaning we have x. So we have 6 plus 10x. The sum of 6 and 10 times a number is equal to, so there's my equal sign. The difference, so the word difference indicates subtraction, of 12 times the same number and 4. Of 12 times the same number, 12 times x, and 4. So subtract 4. The sum of 6 and 10 times a number, the sum of 6 and 10 times a number is equal to the difference of 12 times the same number and 4. Okay, there's my equation. And then solving for that number, I subtract 10x, and I get 6 equals 2x minus 4, and I add 4, and I get 10 equals 2x, and then again, I get x equals 5. Okay, so now what I want you to do is I want you to try the second and third example here and see if you can translate the words into an equation. And that's really what I want you to focus on, is can you translate the sentence into a linear equation? And when we, when you take an assessment with these skills, I'm not just looking for the answer. So it's great if you can kind of like figure out what that number would be in your head, but you want to go through the process of translating the sentence into an equation, because that's going to be worth points on your assessment, is that skill of taking the words and writing an equation based on it. Okay, so right now I want you to see, can I write the equations for these two examples? and then continue the video and see how you did. Okay, so in our second example, we have a quotient. Quotient means we have division. So we have a quotient of triple a number and 7 is equal to 6. There's the translation of that sentence into an equation. Now, to solve this, I'd want to, the inverse of dividing by 7 would be to multiply by 7. So I'd multiply by 7 on both sides. And I'd get 3x equals 42. And then I divide by 3. And I get x equals 14. On my other example, the difference of 4 times a number and 5. The difference being subtraction, of 4 times a number and 5 is equal to twice the number. Solving from here, subtract 4x and -5 equals -2x, and divide by -2, and x equals 5 halves, okay, or 2.5. So now let's look at things that are a little trickier. I actually love these problems. I love, I like doing puzzles, and these problems feel a lot like a puzzle. So the next few problems, some of them use the words consecutive integers or consecutive odd or even integers. So first of all, an integer means we're not having a decimal or a fraction. So when I think of the number set of integers, I'm not going to, so it would be 1, 2, 3, 4, could be negative integers as well, okay? But I'm not gonna go 1, 1.5, 2, 2.2, all of those decimals and fractions, that's not part of our integer set. So consecutive integers, an example of consecutive integers would be 1 and 2, and then 3, and then 4, and then so on. Okay, the consecutive pieces, consecutive means like coming next. So list of integers that are in order, okay, where here's the first integer and the next one is the next integer value, and the next one is the closest next integer value. Doesn't have to start at 1. So another example of consecutive integers would be like 21, 22, 23. Those are consecutive integers. What we need to be able to do is be able to read that in a word problem and know how can we set that up with variables. So if I call the first integer in my list x, then the next integer in my list I could call x plus 1 because it is 1 more than my original integer. And the next integer on my list I can call x plus 2. And the next I could call x plus 3, and so on. But all of these values are based off of this first number. And so that's kind of one of our problem solving tips, is that when you're faced with a number, assign a variable, or when you're faced with a problem that's not like the first page where it's telling you where the variable lives, right? Assign your variable to something and then build your other unknowns off that variable, okay, off that original value. Same idea with consecutive odd or even integers, but now you're only counting the odds or the evens. So again, if I had started at 1, the next consecutive odd integer, because 1 is an odd number, would be 3. And then the next consecutive would be 5, and then 7, and then so on. To build this list in an equation, again, call my first integer in the list x, and to get to the next consecutive odd integer, that would be 2 more than the first. And to the next consecutive odd integer would be the first one plus 4 more. Okay, and I can kind of build this list of either consecutive odd or consecutive even. And so it doesn't matter if I'm looking at a list of even numbers or odd numbers. If I always call the first one x, the next one in the list is 2 more than that. And the next one on the list is 4 more than my original one. So it's nothing to do, the 2 and the 4 have nothing to do with odd or even numbers. The 2 and the 4 have to do with, to go from one odd number to the next odd number, I'm going 2 integers ahead. To go from that odd number to the next odd number, I'm going 2 more ahead, or 4 more from the first one I started with. Same with even, okay? So let's look at an example of why we even care how to build this list. So it says 2 consecutive integers, find 2 consecutive integers whose sum is 45. Again, you may be able to do this in your head, but part of your assessment grade is being able to build the equation. So from this, I have to build my equation. two consecutive integers, not odd or even, just consecutive integers. Here's a number directly numbered right next to it, okay? Consecutive integers. If I call the first integer x, then the next consecutive integer would be one more than x, okay? And that's what we had written up here. The sum, so I knew I was adding them, by the way. So the sum of two consecutive integers is 45. And then from there, I can solve, so I have like terms to combine, and 2x plus 1 equals 45. Subtract 1, and 2x equals 44. Divide by 2, and x equals 22. Now, when I have an application problem like this, it's not just asking me for what x is, it's saying find what consecutive integers would make this true. So my answer should really be, well, 22 and 23 would be the two consecutive integers that added together give me 45. So actually go back and answer the question, okay? Same thing on our second example, except this time it says consecutive even integers, and it's asking for 3 of them. So there's 3 consecutive even integers whose sum, again, sum meaning I have addition, is 72. So consecutive even or odd integers, call my first number x. The next even integer after that would be x plus 2. The next even integer after that would be x plus 4. And it's the sum of integer 1, integer 2, and integer 3. 3 consecutive even integers. The sum of these 3 is 72. Combining like terms here, I have 1, 2, 3 x's, and positive 6 equals 72. Subtract 6, and 3x equals 66. And divide by 3, and x equals 22. Again, I don't want to just circle x equals 22 and move on. I want to find the 3 even integers. So if x is 22, then x plus 2, the next even integer would be 24, and x plus 4, the next even integer would be 26. Those are my 3 even integers that add up and give me 72. So now I want you to just try the next example, because then it gets a little more fun after that. I love 4 and 5, but we'll do those together. So I want you to try to set this up before moving on, and then we'll continue from there. Okay, so let's look at this example. Now I haven't finished this yet. I just started with this, 2 consecutive even integers, and I knew that they were the sum. So here's my 2 consecutive even integers. And it says the sum, so that, and this is where it gets tricky, the sum of the larger and twice the smaller is 62. So when I look at this, I know that here's a list of integers. Now this would be the smaller value, and when I add 2, that would be the larger value. So I'm adding the larger one to twice the smaller, which means I need to add a 2 there. Okay. Now I have 3 x's all together, plus 2 equals 62, and I subtract 2, and I get 60, and then x equals 20. If x equals 20, then my consecutive even integers would be 20 and 22. And I can do like a quick little check. So the sum of the larger, 22, plus twice the smaller. So 22 plus 40, twice the smaller. Yep, that gives me 62, and these are consecutive even integers. Okay. Now, 4 does not use even or odd integers, and it doesn't use consecutive integers. It uses just 3 numbers. Okay, so I know that there's the sum of 3 numbers, sum meaning addition. So I'm adding 3 numbers together, and it's equal to 23. And then it gives me what I call a puzzle problem. So it says the second number is 7 less than double the first number. The third number is 3 times the first number. What are the 3 numbers? So this is where that problem solving hint comes into play, where I'm going to assign a variable to something that I can then relate the other pieces of the problem too. And so kind of the key here is that both the second number and the third number are being related to the first number. That's a really important thing to notice. Both the second and the third have the first number mentioned in it. So if I call, and I encourage you to organize your work in this way. So I always kind of over to the side, build my numbers, and then I'll do the equation afterwards. If I call the first number x, okay, then I can build what the second number looks like because I know the second number is 7 less than double the first number. The second number is 7 less than double the first number. I'm plugging x in for the first number. So the second number is 7 less than double the first number. The third number here is 3 times the first number, is 3 times the first number. Okay, so do you see how that hint works where I give something a variable and then I build the other things off of that variable? And I know that the sum of these numbers is 23. So I'm going to have my first number plus my second number plus my third number. So first number, second number, third number is equal to 23. That's the trick, right? Once I'm here, it's just equation solving. So I have, let's see, 6 x's all together minus 7 equals 23. And I add 7 to both sides. And I get 6x equals 30. And I divide by 6 and x equals 5. That doesn't solve the problem. The problem is saying, well, what are the 3 numbers? So now I want to go back and I need to figure out what the 3 numbers are. So my first number, x, would just be 5. So one number is 5. The second number is 2 times 5 minus 7. Well, 2 times 5 is 10 minus 7. Okay, so my second number is 3. And my third number is 3 times x, or 3 times 5, would give me 15. Okay, so here are my 3 numbers, the 3 missing numbers, where the second number is 7 less than double the first, and the third number is 3 times the first. And they do add up to 23 if I check it. Let's look at one more kind of puzzly problem like this. It's a little different. It says the sum of 2 numbers is 6. So again, we know we're going to add them together. The second number is 10 less than 3 times the first number. What are the numbers? So again, over to the side. This one's different just because it's a little bit easier because I only have 2 numbers to think about. But again, we have to assign something a variable. So I'm going to call the first number x. If I call the first number x, the second number is 10 less than 3 times the first number. Is 10 less than 3 times the first number. There's my second number written in it as an expression. And I know that the sum of the first number plus the second number is equal to 6. And now all the hard part is done. We're just going to solve the equation. So I have 4x minus 10 equals 16, or 4x minus 10 equals 6. I added my 10 over in my head. 4x minus 10 equals 6. Add 10 to both sides and 4x equals 16. And then divide by 4 and x equals 4. Okay, now I'm not done. If x equals 4, okay, so my first number is 4, and the second number is 3 times 4 minus 10, or is 12 minus 10, the second number is 2. Those add up to 6, and the second number is 10 less than 3 times the first. Okay, so there's a few things here. You can't just find 2 numbers that add to 6, or up here find 3 numbers that add to 23. They have to fit the puzzle. So they have to fit the rules that are described in the problem. Okay, and that's why we need to create this structure for my equation to figure out what what the answer to that puzzle is. Okay, so then on the back page are just some other things we may see. So measure of angles within a triangle, perimeter of rectangles, so some stuff that we've seen before. In our triangle, so something we should know is that a triangle always totals 180 degrees. So all of the angles inside my triangle total 180. Perimeter, so knowing that the perimeter around an object, if I add all of my sides together, so if I call this X and this Y, then the perimeter around a rectangle would be 2X plus 2y, just giving you kind of a formal equation, but perimeter means going all the way around that shape. Okay, that's the perimeter of my rectangle. Okay, or perimeter of an octagon, I'd add up all 8 sides all the way around, but I'm adding up all of the sides. My computer might die on me while we're having this video lesson, which means that you may have to watch these 3 examples on the next video. We'll probably end up having to post 2 videos for this one. So what I'm going to do is I'm going to stop my video so that I can stop it before my battery dies. And I want you to try 6, 7, and 8. And then I'll either post my solutions or I'll post a short little video going over 6, 7, and 8. And then once you are done with that, you have some homework that will challenge